This portion of the video is to help you with the problems associated with circles. This first problem uses, here you've got the radius is 12, radius is 12. You're hunting for this little portion right here. Notice that this is a tangent because we're given that tangent things, segments that appear tangent are. So you can set this up with the Pythagorean theorem. Your hypotenuse is this length, which is x plus 12 squared using the Pythagorean theorem, and our legs are 9 squared plus 12 squared. Now when we work that out, and you can see it on the document where I worked everything out, you're going to end up with x squared plus 24x minus 81 equals 0. So factor that. Solve each portion. Now we're looking for a length. X is a length here, and so it can't be the negative 27. So 3, and 3 does work. For the next problem, for problem number 2, we have, we know that this entire length is 24. So we also know that we have this perpendicular radius, and so we know that it bisects it. So we know this is 12 and this is 12. Remember that one of the things that I told you that will help you tremendously is if you draw in a radius to make a right triangle. All the radii in a circle are congruent, so I know this one's 13. So I have a right triangle there. I'm looking for this part. This is 12 and this is 13. So that's actually a Pythagorean triple. You can confirm that using the Pythagorean theorem. So the answer is 5. Here we have an inscribed angle QRS. The inscribed angle is 1/2 its intercepted arc. Since we know this is 40, this has to be 80. Now I'm using that because I see that Z is part of this semicircle. A semicircle has 180 degrees, so 180 minus 80 leaves me 100 for Z. Number 4, we use the fact that the segments, the product of the segments equal each other. So 6 times x equals 8 times 15. So I have 6x equals 120. So x is 20. This we use the theorem of the outside times the whole equals the outside times the whole. So we have the outside is 8 times the whole is x plus 8 equals 10 times 10 plus 6. So we have 8x plus 64 equals 10 times 16, which is 160. And if you work that out, you end up with x is 12. Over here, again, same thing. Outside times the whole is going to give us 6 times 6 equals the outside times the whole, which is 2x. So we have 36 equals 2x squared. Divide both sides by 2. Take the square root. And so that's going to be 3 square root 2 equals x. Number 7 is a little bit more complicated. Here we know that a few facts I didn't write down here are that OQ is a diameter, so is UR, and also RS and ST are tangents to each other. So we know, or tangents to the circle, excuse me. So we know those are congruent. We also have shown in class that this is going to be bisected. And we know these are radiuses, so you could go through and prove that to yourself if you want to, that those are congruent triangles. All right, we also know that if we have a quadrilateral that has 360 degrees, since RS and ST are tangent to the circle, we know that they form 90 degrees. So what's left of that 360 degrees is what RPT measures, which is 148. And then each part is going to be 74. So I also know this is 74. I also know that I have an isosceles triangle here. So these two base angles are congruent. So I know that 180 minus 74 gives me 106. And so those base angles have to split that. So I know that one of the things that I'm hunting for is this one. So it's going to be 1/2 of 106. So that one's 53. Okay, so that gives us UQP is 53. The other one that we're hunting for is this one. We know these are 74, so we have 74, 74, and this forms a semicircle, so I know that that one is 32. Number 8. Okay, this one is actually a lot more simple than it appears in its beginning. I can see that these chords, DC and AB, are the same distance from my center. So I know their intercepted arcs are the same. I'm asked to find AB, so there you go. All right, this next one is, I know this distance is 2. I also know that this is perpendicular, so this is 2. So when I connect here, I know that this is a 45-45 triangle. So if this is a 45-45 triangle, this one over here is 2. So I know this is a right angle. So the measure of arc B has to be 90 degrees because this is a central angle. ACB is a central angle, and it equals the measure of the arc. All right, this ends this section. So the next section will be coordinates in a plane and some polygons.